You know that Ethernet cable, the one we plug in all the time without a second thought? It might just look like a boring old plastic tube, but it is hiding some seriously brilliant engineering. Today, we're going to peel back the layers on this everyday piece of tech. Let's get into it.
Welcome to Super Courseva. Unlock the secrets of the internet and master computer networking. Let's dive in.
So to really get what makes it so smart, we have to kind of take a journey inside, peel back the plastic. So what secrets are actually hiding in there that make our whole digital world spin?
All right, the very first secret is a physical thing. It's totally critical, but it's completely hidden from view. We are talking about the twist. Yeah, the simple twist in the wires. Let's take a look.
So if you were to actually slice open an Ethernet cable, the first thing you'd get through is that outer plastic sheath. Inside, you'd find 8 little wires. But here's the thing, they're not just a jumbled mess. They're neatly grouped into 4 pairs. And this is the really important part. Each of those pairs is twisted around itself.
Now, you might be thinking, okay, so what? They're twisted. But this is not some random thing that happens during manufacturing. No way. That simple little twist is an incredibly clever and very deliberate piece of engineering that solves a huge problem in electronics. And that problem is called electromagnetic interference. You might have heard of it as EMI. Basically, it's just unwanted electrical noise from all the other electronics around you. And that noise can totally mess up your data. The absolute genius of the twist is that any interference that hits one wire in the pair is the exact opposite of what hits the other wire. So they just cancel each other out. It's a brilliantly simple form of noise cancellation.
Okay, so we've seen the physical road, right? The wires. But what about the rules of the road? How does our information actually travel through these cool noise-canceling wires? Well, it all comes down to the direction of traffic flow.
So, data travel basically boils down to 2 fundamental modes. First, you've got Simplex. Think of this like a one-way street. Data only flows in a single direction, period. Then you have Duplex, which is way more common for what we do. That's our 2-way street, where information can go in both directions.
The perfect real-world example of Simplex: a baby monitor, right? It sends sound from the baby's room to you, but you can't talk back through it. It's just a one-way broadcast. And even though it's pretty rare in modern networks, you gotta understand Simplex to get what comes next.
Okay, this is where it gets really, really interesting. Because that 2-way duplex street we just mentioned, it actually has 2 different ways of managing all that traffic. And believe me, the difference between them is absolutely critical.
So first up is what we call half-duplex. And the easiest way to think about this is a walkie-talkie. You can talk, your friend can talk, but you absolutely cannot talk at the same time. You have to take turns. One person sends, the other receives. I mean, anyone who's played with walkie-talkies knows the drill. You say what you need to say, and then you have to use that magic word, over. That one word is the signal that you're done, and it's the other person's turn to talk. That right there is the whole idea of half-duplex. And what happens if you both try to talk at once? It's just a garbled mess, right? Well, in networking, that's called a collision, and it means that the data from both sides gets totally scrambled and lost. It's a huge problem. So the solution is Full-Duplex. This is the telephone method. With Full-Duplex, both devices can send and receive data at the exact same time, no problem at all. How does it do it? Well, it uses different pairs of those twisted wires we talked about earlier, one pair for sending and another pair for receiving. And we all know this from just living our lives, right? You're on a phone call, you get all excited, and you interrupt your friend mid-sentence. They still hear you, you still hear them. The conversation just flows. There are no collisions. That's the power of Full-Duplex. So let's just do a quick recap of the showdown here. Half-duplex, you're taking turns, like a walkie-talkie, and you risk collisions. Full-Duplex, you're having a simultaneous conversation, like a telephone call, and there are no collisions. The difference is all about speed, efficiency, and just plain reliability. Now, I know this might all seem a little theoretical, but stick with me, because there's a huge practical takeaway here. Knowing this stuff is like having a secret diagnostic tool for figuring out when something is going seriously wrong with your network.
Okay, so why did we just go through all that? Why does it matter? Because understanding the difference between half and full duplex can instantly turn you into a network detective. Here's what you need to be on the lookout for.
Here's the simple, honest truth. Any modern wired network that you use, at home, at the office, you name it, is built from the ground up to run in full duplex mode. That is its default, healthy, expected state.
It's designed for that fast, two-way conversation. So if you're ever looking at your network connection status and you see it's running in half-duplex, that's it. That is the big red flag. That's the alarm bell telling you something's not right.
And this is really the key takeaway from all of this. If a modern connection drops down into half-duplex mode, the devices are basically screaming at you that the physical connection is bad. They're being forced to slow way down and take turns just to keep the data from getting corrupted.
So what's causing it? Well, the most common culprits are usually a physically damaged cable, maybe it's been bent or crushed, some really bad electrical interference, or a faulty network port on your computer or your router. Seeing half-duplex tells you exactly where to start looking. So, the next time you plug in that plain old cable, you'll know about the hidden genius that's packed inside it, from that noise-canceling twist to the complex rules of the road that it follows. And it kind of makes you wonder, what other invisible signals and amazing systems are working all around us all the time? Thanks for tuning in.